Indices are one of the most important operations and calculations in maths as it provides abbreviations and lets us simplify extremely large or small numbers. Hello, my name is Mishti Kaushal and today I'll be explaining and solving questions which include negative indices with square and cube roots. Before I begin with the negative indices with square and cube roots, I would like to discuss and summarize the 9 index laws which will help us solve the examples, mainly the last 3 laws which directly relate to our topic. The first law states that any 2 or more expressions that are multiplied by each other, the powers are added. The second law states that if any number or pronumeral is divided, then the powers are subtracted. The third law presents that any expression with a power of 0, the answer is always 1. The fourth law presents that when a power is raised to another power, the indices are multiplied. The fifth and sixth law presents that any power outside the bracket will multiply all the powers inside the bracket. The seventh law shows that any expression to a power of negative indice is written in a fraction where 1 is in the numerator. The eighth and ninth law states that any number or pronumeral under a square or cube root can be written as a power of half or in cube root as a power of 1/3. Now let's begin with the examples. Our first example is slightly simple. Example 1. Simplify the following with no negative indices. So we put the square root to the power of a half, so 25 to the power of negative 2, a to the power of 8, m to the power of 10, bracket, and everything to the power of a half. So we do 25 to the power of negative 2 first, since we don't want any negative indices. So that is 25 to the power of negative 2 times a half. 2 cancelled with 1 and that becomes negative 1, which is 25 to the power of negative 1. That is simplified to 1 over 25. Let's do the next pronumerals. A to the power of 8 times a half and m to the power of 10 times a half. This is written as 2 simplified to 1, 8 becomes 4, 2 simplified to 1 and 10 becomes 5. So that's 1 over 25, a to the power of 4 and m to the power of 5. This is written as, in a more simpler version, to the final answer of a to the power of 4, m to the power of 5 over 25. Let's continue with example 2. Evaluate the following. So let's start with the numerator. So it's bracket 4 to the power of negative 3, bracket close to the power of 1/3. We open the bracket and that is 4 to the power of negative 3 times 1/3. That can be crossed off, which is 3 becomes 1 and negative 3 becomes negative 1. That is 4 to the power of negative 1. That gives us 1 over 4. Now we do the next bracket and we open the bracket, which is multiply by m to the power of 14 times a half and n to the power of 16 times it by a half. So that is a quarter times 2 becomes 1, 14 is 7, 2 becomes 1, 16 is 8, and m to the power of 7 times n to the power of 8. The end answer for the numerator is m to the power of 7, n to the power of 8 over 4. Now we solve the denominator. Since there's a cube root, we put everything to the power of 1/3. So 216, m to the power of 9, n to the power of 3, bracket closed, everything to the power of 1/3. So 216 to the power of 1/3 is 6. M to the power of 9 times 1/3 is m to the power of 3. N to the power of 3 multiplied by 1/3 is n to the power of 1. Now we do the division. m to the power of 7 n to the power of 8 over 4 divided by 6 to the power of 1 m to the power of 3 n to the power of 1 over 1. We do the reciprocal and we multiply. M to the power of 7 n to the power of 8 over 4 multiplied by 1 over 6 to the power of 1 m to the power of 3 n to the power of 1. So that gives us a final answer of m to the power of 7 n to the power of 8 over 24 m to the power of 3 and n to the power of 1. So the final answer is we subtract the powers, m to the power of 4 n to the power of 7 over 24. Thank you very much for listening, and I hope now you know how to solve questions which include negative indices with square and cube roots.